To our fourth training video in the series for Project WAfLS. This particular video is going to cover the core OWL survey protocol. At each point, we're going to talk about survey dates and times, the core data sheet, how identification, and give you some suggestions on particular searching techniques. This training video will give you most of the information, but we still encourage you to read the protocol and have a copy of the protocol with you when you go into the field. There's a lot more detail in there and about specific values, etc. So first of all, the survey dates. When on the calendar to do your surveys, we are asking you to complete 2 visits to your grid within the designated time periods, and we do prefer at least 1 week in between your 2 visits. Each survey window is 3 weeks long, so you can pick any day in the first 3 weeks and then any day in the second 3 weeks, and once again we hope that there's a week in between. If you can't, that's okay, but if most everyone puts a week in the middle, we will be good. Here's an example for grids in Utah less than 5,000 feet. The first visit is between March 1st and the 21st, and the second visit will be between March 22nd and April 15th. So the windows change based on the elevation of the grid. The timing can be viewed for your particular grid by clicking on the zoomable map, or it's printed on the top of the one-page maps, and I'll show you 2 examples there. On our core website, if you zoom into your particular grid, in this case Wyoming 36, you can see that the timing for this visit is the first visit between March 24th and April 14th, and the second one between April 15th and May 6th. Or in this case for California 27, on the one-page map printed across the top are the survey windows for that. So 2 different places for you to get the survey dates for your visit. Now let's talk about survey timing. The survey timing is very important that we get this one right, and I'll explain why here. Short-eared owls are crepuscular, and so we're looking to detect them right before darkness, or what we call the end of civil twilight. That's about 30 minutes after sunset. What we're looking for is the courtship flight of the male. He will do this elaborate flight display, spiral up in the air 500 feet or higher, clap his wings and tumble out of the sky, circle back up again, and repeat that. That's the point at which these owls are most easily detected, and our survey dates are chosen to try to coincide and detect this flight display. So that's why the dates are important, and it's also why the timing is important. Larson and Holt, Matt Larson, our Montana State Coordinator, did some research and really evaluated that the probability of detection gets much higher as we approach total darkness. So the survey period is 90 minutes long. We begin 100 minutes before darkness, or the end of civil twilight, and we finish 10 minutes before the end of civil twilight. At that point, it's beginning to get quite dark, so it'll start to be difficult to see birds at a distance, and definitely more difficult to identify them. And you can get the start and end times for your particular grid and the particular dates from our website, and I'll show you right here. On the survey resources under protocol, we have the protocol link, the data sheet, and then down here at the bottom we have the link to your start times for your survey grid. You click on that link, choose your state, and then download your grid display. And that will be a page like this with the grid on the left-hand side, in this case Montana Route 16, all your possible survey dates, and the start time. We want you to start your first point as close as possible to these times, and then instead of an end time, we want you to start the last point no later than this time on the right. So if we say we're surveying on April 1st, no foolin', we would begin this first point at 1834 or 6:34 p.m. and we would begin our last point at 1959 or 7:59 p.m. If we got to that last point and it was 8:03, we wouldn't do the point, basically. So we need to start it by this time. And these are available for all 400 plus grids in our survey protocol. So why is it important that we focus on this 100-minute to 10-minute interval right before dark? And that comes down to the detectability of the owls themselves. So given, this is a graph from our 4-state results in 2017 that shows that the probability of detecting the owl increases as we approach the end of civil twilight. And this is the probability of detecting an owl given that there is one there. So if we were to look at 10 minutes before the end of civil twilight on the right-hand side here, and there's an owl within a kilometer of that point, we have a 40% chance of detecting it. But if we go clear out to 100 minutes before, we only have a 26% chance of detecting that owl given that it's there. And so that's why we want to be within this window. If we were to start a half hour earlier than that, it drops down well below 20%. So last year we had to drop a number of survey points because people started them too early. So please download your start times and follow them very precisely, please. So now let's get into the core OWL protocol. This is an excerpt from our data sheet. Across the top we see a lot of just the basic information: what state, what grid number, the date, is it your first or second visit. Please list all surveyors that are participating. If you have 5 people, there should be 5 names there. Temperature to the nearest 5 degrees. Wind, this is a Beaufort scale, and there's more information in the protocol and some examples of how to calculate that Beaufort scale, whether branches are moving on the trees, things like that. So that's one of the reasons you need the protocol with you. And then the cloud cover: clear, partly, mostly cloudy, or fully cloudy. On the mileage and time, we break these down into 3 categories: whether you are participating in this survey as a volunteer, whether you're being paid from a federal source, or whether you're being paid from a non-federal source, so state or NGO source. And even if you're a federal biologist but you're volunteering on the program, you're not being paid, and you're driving your own vehicle and not being reimbursed, then we classify you as a volunteer. But if you're driving a agency vehicle and getting paid for it, then please allocate your miles and your hours in the appropriate category. Miles are vehicle miles, so we don't replicate that by the number of surveyors, but hours is the total contribution. So in this case, there were 2 of us surveying this route. The survey itself was an hour and a half, so an hour and a half times 2, 3 hours. Transportation to and from was an hour and a half, so times that by 2, and then all the training, sign up, data entry, etc. Adds up to a total of 9 hours reported in there. And then the affiliation, we try to capture that. This is an organization that we would want you to give credit to for your participation. We do summarize all of the various organizations that participated in the survey, so you can put that in there. Now at each point, we're going to ask you to put in the start time and 24-hour time here, no colons or punctuation in there. So 1756 is the equivalent of 5:56 p.m. And then the GPS coordinates I covered in the last training video: decimal degrees, latitude and longitude here. And you'll do that for each point. Now when we get down into the core OWL protocol, there's a number of points we need to gather, and you're only going to fill this part out if you detected an owl, and each unique owl represents a row on this table. So the first is how the owl was initially detected, by sight or by sound. So here I have an example of 2 different owls. The first one I detected by sight, the second one I detected by sound, but then maybe I saw it, but it's how you first detected it. And then the initial direction and the initial distance. We're using meters here, which are roughly equivalent to yards, but that can be difficult to estimate. So the way that we suggest is that local power lines or power poles are usually 100 meters apart. So as you're estimating distances, less than 200 meters would be less than 2 power poles away, 2 to 400 would be 2 to 4 power poles, 4 to 6 power poles, or greater than 6 power poles away. and you just check what the initial distance. If the bird's flying towards you, it's still the initial distance when you detected it, even if it flies directly over your head. And then the habitat that the owl was above when you first saw it. So you may be in grassland, but the owl is in shrubland. Or you may be in shrubland and the owl is above agriculture. So we have you note that down there. Then we get to the minute-by-minute portion of the protocol. It's a 5-minute survey, and we want you to check every individual minute that each individual owl is seen in. So this first line here represents an owl that I saw in minute 1, I saw it in minute 2, I saw it in minute 3, then let's assume it flew off. I did not see it in 4 or 5. The second one, I detected it by sound in minute 2, then maybe I saw it in minute 2, 3, 4, and 5, so it gets 4 checks through there. And then the last part is just listing all the behaviors that we see this owl perform and any vocalizations you might hear. We'll cover some of that in the identification guide up next. And then we want to emphasize that the analysis protocol we use is robust against false negatives. That means that if you don't detect a bird, that is okay, or if you're not sure of the identification and you don't list it as a detection, that's okay. But what we don't want you to do is think maybe it's a short-eared owl and you write it down as a short-eared owl. Our analysis is not robust for that condition. So we've put this separate line in here for you to say, well, how many owls did you possibly see but that you weren't able to 100% confirm? So in this case, this example, I was able to confirm the identification on 2 of them, but then I saw 1 more that, that I could not 100% confirm. So I didn't list it up in the table. I add it down here in this second question. So now, well, let's give you some advice on the searching at the point. If you have multiple observers, I suggest that you divide up the roles before you begin. Maybe it's someone is looking high and someone is looking low, or one person is looking on the east side of the road, the other person is looking on the west side of the road. What we don't want is 2 or 3 people standing there all looking at the same direction. There's a lot of habitat to cover in a short amount of time, so plan your roles, be as efficient as possible. During the first minute, what I usually suggest is that you search the entire landscape. That's 360 degrees, high, low. We want you to look at all the fence posts that are visible, shrub tops. These birds like to perch on the top of shrubs, on top of fence posts, even on power lines. Look for trees, and they can also be on the ground. If you detect any, fill out the row in the table. And then each subsequent minute, the first thing I do when the minute turns over is I try to relocate all the owls that I observed previously, and then I repeat or continue the search of the whole landscape. At the start of minute 3, try to relocate any previously detected owls, and then search the landscape again for minute 4 and minute 5. So that concludes this particular training video. Next time we'll jump into the habitat data quantification. But as always, we encourage you to follow us on the Project WAfLS Facebook page. And here's a shortened link to the full website that has all of our resources, sign up, etc. This bit.ly link is case sensitive, and you cannot have a / at the end. Thank you for your time, and thank you for your interest in this important program.